Welcome back, peeps. Let's keep going. We're talking about completing the square now. So I need to add a number to both sides here. How do I figure out what that number is? I take this value, the b, I divide by 2, and then square it. 6 divided by 2 is 3. 3 squared is 9. So 9 is what I'm going to add to both sides. Why did I do that? Because now this factors. 1 times 9 is 9, b is 6, and 3 times 3 is 9, 3 plus 3 is 6, so this factors into x plus 3 times x plus 3, and that is x plus 3 squared equals 49. Why is that cool? Because now I can take the square root of both sides. Do not forget to put a plus or minus on the side opposite the x. Square root and square cancel each other out, so I get x plus 3 equals plus or minus the square root of 49 is 7. And then to get x by itself, I just subtract both sides by 3. And I get x equals negative 3 plus or minus 7. Not good enough, because I know what negative 3 plus 7 is. It's 4. And I know what negative 3 minus 7 is. It's negative 10. So, the answer to this, the solutions to part 1, x equals 4 or x equals negative 10. Part 2. Half of 10 is 5. 5 squared is 25. So I'm adding 25 to both sides. This is a trinomial square now, and it's going to be x minus 5 squared. Negative 29 plus 25 is negative 4. Now I can take the square root of both sides, plus or minus over here, and I get x minus 5 equals plus or minus, square root of 4 is 2, but the square root of negative 1 is I. So this is plus or minus 2i. Add 5 to both sides, and x equals 5 plus or minus 2i. And that, you can leave like that, because what is 5 plus 2i? It's just 5 plus 2i. You might see the answer written like this sometimes. And what's 5 minus 2i? Well, it's just 5 minus 2i. So this is just kind of a more compact way to write the same information. Alright, simplify each expression and write your final answer in a plus bi form. So 4 minus 5i minus the quantity 7 plus 9i. So that means I'm going to do minus 7, and I'm also going to do minus 9i. Like terms, 4 minus 7 is negative 3, and negative 5i minus 9i is negative 14i. And that is in a plus bi form, where a is negative 3 and b is negative 14. Alright, part 2, multiplying two complex numbers. And you just do FOIL like you've always done. 3 times 4 is 12. 3 times negative 2i is negative 6i. 5i times 4 is positive 20i. And 5i times negative 2i is positive times negative is negative. 5 times 2 is 10. I times I is I squared. Alright, so this is 12. Here's some like terms. Negative 6i plus 20i is going to be plus 14i. And then I squared is negative 1. So this is going to be negative 10 times negative 1, which turns into positive 10. So 12 plus 10 is 22. So we get 22 plus 14i. And that is in a plus bi format as well. Now dividing complex numbers is a little tricky. There's a trick that you learn where you multiply the top and bottom by the conjugate of the bottom. The conjugate is just the same two numbers but with the opposite sign in between them. So the conjugate of 3 minus I is 3 plus I. So I'm going to multiply the top and bottom by 3 plus I, because essentially what I'm multiplying by here is 3 plus I over 3 plus I is 1. And I'm allowed to multiply by 1 because it doesn't change the value of what I started with. Alright, so on the top, 4 times 3 is 12. 4 times I is plus 4I. 5i times 3 is plus 15i. And then 5i times I is plus 5i squared. On the bottom, 3 times 3 is 9. 3 times I is plus 3i. Negative I times 3 is minus 3i. Negative I times I is minus I squared. Now both of these I squareds are turned into negative 1s, so this is going to be minus 5, and then minus negative 1 is plus 1. So on the top, 12 minus 5 is 7. 4i plus 15i is plus 19i. And on the bottom, 9 plus 1 is 10, and 3i and negative 3i is 0, so it's just this. Now, is this an a plus bi form? Not quite yet. So I can break apart this into two fractions. 7 over 10 plus 19 over 10 I. Now it's in a plus bi format. Okay, find the x-intercepts and the vertex, and then graph the parabola. Well, the x-intercepts happen when y equals 0. So we got 0 equals x plus 1 times x minus 3. And this product will equal 0 when one or both of these factors equals 0. So x plus 1 equals 0 will give us one solution. X minus 3 equals 0 will give us another solution. Subtract 1 from both sides here, and we get x equals negative 1. Add 3 to both sides here, and we get x equals 3. Remember, we made the y value 0 for each one of these, so this gives us 2 points. Negative 1, 0, and 3, 0. Now we need to write the equation in standard form, and that's going to happen by using the distributive property twice, or doing FOIL as you may know it. Y equals x times x is x squared. X times negative 3 is negative 3x. 1 times x is positive x. 1 times negative 3 is minus 3. Couple of like terms here, and y equals x squared minus 2x minus 3. So now, using the standard form, we are going to identify the x value of the vertex. So the x value of the vertex is x equals negative b over 2a. So negative b is negative 2. And a is 1, so 2 times 1 is 2. So now it's negative, and then negative 2 over 2 is negative 1. So negative of negative 1 is positive 1. Now we need to plug this value in to the standard form equation to figure out, or you could plug it into the original equation, figure out what the y value of the vertex is. I'll plug it into the original. Y equals 1 plus 1 times 1 minus 3. 1 plus 1 is 2. 1 minus 3 is negative 2. So y equals negative 4. So the vertex is x is 1, y is negative 4. Now we can use the standard form of the equation to find the y-intercept. And the y-intercept happens when x equals 0. So I'm going to take this and put zeros in for x. Y equals 0 squared minus 2 times 0 minus 3. Well, that's 0 and that's 0. So y equals negative 3. So that gives us the point 0, negative 3. Now we're going to use the intercepts and the vertex that we found in order to graph this here parabola. Alright, so negative 1, 0. Starting at the origin, negative 1 in the x direction, 0 in the y direction. Draw your point and label it. 3, 0 is positive 3 to the right in the x direction and up 0. The vertex is 1, negative 4, so starting at the origin, to the right 1 and down 4. The y-intercept is 0, negative 3, so over 0, down 3. Now through the vertex we have what is called the axis of symmetry, and it acts as a mirror for each side of the parabola. So this point here has a mirror image over here. This point here also has a mirror image over here, which is going to be at 2, negative 3. Once you got several points, you can draw a nice smooth curve going through all of them, and there you go. Now what do you say we solve this system? Let's start by solving the first equation for x. If we add 6y to both sides, we're going to get 2x equals 6y. Then divide both sides by 2, and we get x equals 3y. Now we're going to substitute this value of x into the second equation. So instead of x squared, it's 3y quantity squared. 3y times 3y is 9y squared. Plus y squared equals 20. 9y squared plus y squared is 10y squared equals 20. Divide both sides by 10, and we get y squared equals 2. Square root of each side, plus or minus, and we get y equals plus or minus square root of 2. So those are our two y values. So all we got to do is plug those back in to figure out our x values. So when y is positive square root of 2, we can plug that in here and get x equals 3 times y, which is 3 times square root of 2. So here we get an ordered pair of 3 radical 2 comma radical 2. When y equals negative square root of 2, we still use x equals 3y, but now y is negative square root of 2. So x equals negative 3 radical 2. And that gives us the ordered pair negative 3 radical 2, comma, negative radical 2. And there you have it. Remember to use the pause and rewind button on your video player, and email me if you have any questions. Peace.